Okay, so today we're going to continue talking about stoichiometry. So this is going to be part 2. So we're going to take our boxes a little bit further. Reminder, you're going to want access to this, which is the whole stoichiometry process, and probably a periodic table, okay? And you'll also need a calculator. So make sure you have those things kind of ready to go. So I'm going to do 2 examples on the front side and then 3 examples on the back, because those are the longer ones. And then again, your assignment will be wherever it says assignment, okay? So this says, how many grams of iron are needed to produce 7.73 moles of iron 3 oxide? So we can start with what we know. So that's going to be our given, 7.73 moles. And then we need a formula for iron 3 oxide. Well, that's going to come from the balanced equation. So Fe is iron, and then this is oxygen. So iron 3 oxide is going to be Fe2O3. Okay, so that's going to be our symbol for that. Okay, and I want to remind you that you're not going to write that number in front. That is not part of the formula. That is going to be used in our mole ratio in just a minute, which we're going to circle, okay? So only the symbol is what we're going to be using when we write it down, okay? So just like before, let's put our finger on kind of where we're starting and what we're looking for. It says how many grams of iron, and we're starting with moles of iron 3 oxide. So we're starting with moles of substance A. We're going to use our mole ratio to get to substance B. And then from there, that will be another box. And then from there, we're going to go to grams. So we're going to start with our first box here. We're going to use our mole ratio in the next box. And then we're going to go to grams of the new substance. Remember, the mole ratio is what allows us to go from substance A to substance B. Okay? So we're going to have moles here. Nothing goes in this box. If moles is on top, then moles has to be on bottom, so we can cancel it. Okay, and just like in the last video, the first time you have moles on bottom, I want you to circle it because that is your mole ratio. Okay, that is the only time you will have moles on top of moles and when you will change the compound. So I'm going to new substance B. We're starting with Fe2O3, and I'm asking for grams of iron. So the symbol for just iron is Fe. Okay, notice we changed compounds inside the circle. All right, since we're looking for grams of iron, we have to go one more box. Okay, so all of this assignment today will be more than 2 boxes. All of them will have at least 3. Okay, and then if this is moles of Fe on top, I need it to cancel. So I'm going to put moles of Fe on the bottom. And then I can finally go to grams of Fe. Okay, so before we cancel stuff out, let's put in some numbers. Remember, outside of the circle, mole gets a 1. Outside of the circle, mole gets a 1. All right, inside the circle, that's where I'm going to use the numbers in front from my balanced equation. So the number in front of Fe2O3 is a 2, so that's going to go here. And the number in front of Fe is a 4. So that's going to go on top. Remember, inside the circle, the mole ratio is the only time it won't be ones, okay? Or it could be ones, but it doesn't have to be, okay? It can be something else. Outside of that circle, mole still gets a 1. The only time you use those numbers in front is inside that mole ratio circle. All right, grams. If you look back at your little reminder, grams comes from the periodic table. So you'll grab your periodic table. I have one right here. And we're looking for the molar mass of just Fe. So we're just going to look it up. And it's 55.845. So that is going to go in this box right here. All right. So now let's look at what cancels. So I have moles. I have moles of Fe2O3 on the top and moles of Fe2O3 on the bottom. Moles of Fe and moles of Fe are going to cancel. They're on top and bottom, and they match. And I'm left with grams of Fe. Let's go back to the question. How many grams of iron? And that's what I have. Okay. Remember, to solve, you're going to multiply the tops and divide every time there is a number on the bottom. Okay. So I'm going to grab a calculator and type this in. Okay. So we have 7.73 times 4 times 55.845 divided by 2 divided by 1. Okay, so we'll go back. This is our answer, but we're going to round to sig figs. Our very first box is going to tell us how many sig figs. This happens to have 3 sig figs, so I'm going to round this to 3 sig figs. The 3 makes the 3 stay the same. So my answer would be 863 grams of Fe. And I want you to put your answer in a box like I just did. Okay, let's try another one. If 4.5 moles of oxygen reacts with iron, what mass of iron 3 oxide will be produced? Okay, so this time I'm starting with 4.5 moles, and then it says moles of oxygen. Well, oxygen is going to be one of our symbols up here in our balanced equation. You cannot do stoichiometry without a balanced equation. That's going to be O2. Remember, the number in front we're going to use in our mole ratio. So I'm going to write it as O2. Okay, so let's look at our little roadmap for stoichiometry. We are starting with moles of oxygen, moles of substance A, and we're looking for mass, which is grams, of iron 3 oxide. So same deal. We're going to start with moles of oxygen, use our mole ratio to get to moles of iron 3 oxide, and then go to grams. So we're going to need 3 boxes again. This is a box, the mole ratio is a box, and then our grams is a box. All right, so same rules as before. If nothing goes here. If this is moles of O2 and we need it to cancel, we're going to put it on the bottom. Moles of O2. And the first time you have moles on bottom, we're going to go ahead and circle it. That's our mole ratio, which means I get to have moles on top. Now the moles on top is going to be for a new compound. I'm asking about iron, what mass of iron 3 oxide. Well, that symbol is Fe2O3. Okay, I'm going to draw the thing because I'm looking for mass, which is going to be grams. So I got to go one more. So everything on this front part of your assignment will be 3 steps, just like my 2 examples. They'll start with moles and they'll go to grams. All right, so this on top is moles of Fe2O3. So I have to have moles of Fe2O3 on the bottom. Now, this is moles again on the bottom, but it's not the first time. So this is not going to be my mole ratio. This is where I'm going to go to either grams or molecules, whatever I'm asking for. I'm asking for mass, so that's going to be grams. So grams of Fe2O3. Okay, so outside of the mole ratio circle, mole gets a 1. Inside the circle, I'm going to look at my balanced equation. So O2 has the number 3 in front, so that's what's going to go in that box. And Fe2O3 has the number 2 in front, so that's what's going to go in that box. Grams comes from the periodic table, so we're going to have to do molar mass. Okay, I'm going to do it on a separate sheet of paper. So we have, I'm going to go ahead and start a list. So we have Fe and we have O. We have 2 Fe's. Here's our formula. And 3 O's. Okay, Fe2O3 is the formula we're finding the mass for. You should be good at this by now. We've been doing this for weeks and weeks and weeks. So we're going to look up the mass of Fe, which is 55.845. And then our mass of oxygen is 15.999. So we're going to multiply and add those together. Grab a calculator. So we're going to do 2 times 55.845 plus 3 times 15.999. So 159.687 grams per mole. All right, so that is going to go in the box with the missing grams. 159.687. All right, so let's talk about what cancels. Moles of O2 cancels because one's on top and one's on bottom and they match. Moles of Fe2O3 cancel and I'm left with grams. It's asking for mass of iron 3 oxide. Grams, iron 3 oxide. So I set that up right, okay? So now to solve, we're going to multiply the tops and divide the bottoms. So let me get a calculator, scoot that up a little bit. So we're going to have 4.5 times 2 times 159.687 divided by 3 divided by 1. All right, so we're going to round again to sig figs. So this original box here has 2 sig figs in it. So I need to round 479.061 to 2 sig figs. Okay, so 479.061. The first 2 are the 4 and the 7. The 9 makes the 7 round up 1. So it's going to be 480 with no decimal. Okay, if I add a decimal, that makes that 0 significant. And then the unit would be grams, Fe2O3. Okay, remember this is only 2 sig figs. There's trailing 0 with no decimal. Okay, so now on the back, we're going to do those 3 examples there. And this is going to take us further. So this is going to take us from grams all the way to grams. So we have a new balanced equation, but we're going to do the same kind of process, okay? So it says, I'm going to switch colors. What mass of copper is produced if 203.0 grams of aluminum reacts? Okay, so I'm going to go ahead and start with my given. Now, if you write particularly big, you're going to want to write small because we're starting with grams and we're asking for mass, which is grams. So we're going to go from grams to grams. So from grams of one substance, the only place you can go is to moles. Then we're going to have another box to get over here and use our mole ratio, then to grams. So we're going to have 4 boxes. Starting box, get to moles, use the mole ratio, get to grams. So this is a box, this is a box, this is a box, and this is a box. So you need to write a little bit small if you write particularly big. So we have grams of Al. So I'm going to go ahead and draw a line. All right. So we need grams of Al to cancel. So I'm going to put grams of Al here on the bottom so it can cancel in a minute. From grams, the only place I can go is moles. And we're not switching substances yet. We're staying in the same substance. Now, I'm looking for mass or grams of copper. I'm not there yet, so I'm going to have to draw a line and do another box. Right now I have moles of Al. So moles of Al is going to go on the bottom for me to cancel it. And this is the first time I have moles on bottom. So this is my mole ratio. I want you to circle it. And that is when I'm going to switch from moles of one thing to moles of the other thing. And I'm asking about copper. The symbol for copper is Cu. It's up there in the balanced equation. Now, I'm looking for mass, which is the same thing as grams. So I have to go one more box. I told you it was going to be 4 boxes. All right, so this is a box, this is a box, this is a box, and then our last box. So right now on top, I have moles of Cu. I need it to cancel. So I'm going to put moles of Cu on the bottom, and then I'm going to go to grams of Cu on the top. Okay, so now let's fill in some numbers. Outside of the circle, mole is going to get a 1. So that gets a 1, and this one gets a 1. Now this one wasn't circled, even though it's moles on the bottom, because it wasn't the first time. Only the first time do you circle it and use the mole ratio. Other than that, all the other moles will get a 1. All right, now inside the circle, that's where I'm going to use the balanced equation. So the number in front of Al is a 2, and the number in front of Cu is a 3. So that's going to go in that box up there. Okay, that is the only time we use numbers that aren't 1 inside the circle. All right, grams are going to come from, according to our little roadmap, going to come from the periodic table. Now, the nice thing is these are just elements, so we don't have to add anything. So we can just look up the mass of aluminum, which is 26.982. And then our mass of copper, kind of in the middle, is 63.546. Trying to make those decimals bigger so you can see them. All right, so now let's talk about things that cancel. I really want to grab, I'm going to grab a different color so you can see. I'm going to grab a marker. All right, so grams of Al cancel because one's on top and one's on bottom and they match. Moles of Al cancel and moles of Cu cancel. So I'm left with grams of copper and I'm looking for mass or grams of copper. So that part is correct. Now to solve, I'm going to grab something bigger because I want y'all to be able to see it. All right, to solve, you're going to multiply all the tops, and you're going to divide every time there's a number on the bottom. Okay, so let's do that. So we have, I'm going to start here at the top, 203.0 times 1 times 3 times 63.546 divided by 26.982 divided by 2 divided by 1. Okay, so we're going to round this to sig figs. Our original box here has 4. This is a sandwich 0, which always counts, and this trailing 0 has a decimal, so this is 4 sig figs. So this is going to be 717.1. The 3 keeps the 1 the same. So this is 717.1 grams of Cu. So you can kind of copy that down, okay? Let's try another one. Same equation, but different question. What mass of aluminum nitrate is produced if 108 grams of aluminum reacts? So we're going to start the same. 108 grams of aluminum. All right, so let's see on our little map where we're headed. Remember, you don't want to write big, okay? So we're starting with grams of aluminum, and we're trying to get to grams of aluminum nitrate, which is different. So we're going again from grams to grams. So we're going to go from grams to moles, then use our mole ratio, then go to grams of the new thing. So it is going to be 4 boxes again. All right, so on top right now I have grams. So I need grams of aluminum on the bottom so it can cancel. I'm going to go to moles of aluminum. That's the only place I can go. I'm going to show you. From grams, the only other box you can go to directly from grams is moles. All right, so right now on top I'm in moles of aluminum. I need it to cancel, so I'm going to have moles of aluminum on the bottom. All right, this is the first time I have moles on bottom. That is my mole ratio, so I'm going to circle it. I want you to do the same. That means I can go to moles on top and switch substances. So the new thing I'm asking about is aluminum nitrate. So if we look at our symbols up here, it can't be this one because that's copper, and it can't be this because that's aluminum. So the only other thing that contains aluminum is AlNO3, 3. So that's what I'm going to write now in the top box. And then I'm going to draw my line. All right, so right now I have moles of AlNO3, 3 on top. So moles of AlNO3, 3 is going to go on the bottom. And then finally I can go to grams. I told you to write small. It takes up a lot of space. Okay, so let me show you again on the map kind of how we did this. So we started with grams of aluminum. Then we got to moles of aluminum. Then we used our mole ratio. That's this box right here. Then we went to grams. So that's why it was 4 different boxes. Okay, so outside of the circle, mole gets a 1. So both of those boxes are a 1. Inside the circle, we're going to look at our balanced equation to find what numbers are going to go inside. In front of Al is a 2, and in front of AlNO33 is also a 2. So that's going to go on in that box. Grams comes from the periodic table. So we already looked up our mass of aluminum, and that was 26.982. And then we have aluminum nitrate. So we're going to have to do molar mass for that one. So I'm going to grab the paper I just used earlier. So we have AlNO3, 3. So in this formula, we have Al, we have N, and we have O. There's 1 Al, 3 Ns, remember this number multiplies, and 9 oxygens. All right, we just looked up Al. It was 26.982. Nitrogen is 14.007. And oxygen, you should know, is 15.999. Okay, so we're going to multiply and add those together. So 1 times 26.982 plus 3 times 14.007 plus 9 times 15.999. So you should get 212.994. And that's grams per mole. All right, so I'm going to move this out of the way so I can fill it in. 212.994 grams per mole for aluminum nitrate. Okay, so things that cancel, where'd that orange go? Okay, so grams of Al cancel because they're on top and bottom and they match. Moles of Al cancel because they're on top and bottom and they match. Moles of AlNO3 and moles of AlNO3 cancel, and I'm left with grams. It says mass, again that means grams, mass or grams of aluminum nitrate, and that's what we're ending with. To solve, we're going to multiply the top and divide the bottom. Okay, so here we go. 108 times 1 times 2 times 212.994 divided by 26.982 divided by 2 divided by 1. Okay, so again, we're going to round this to sig figs. The first box here has 3. That's a sandwich 0. So it's going to be 853 because the 5 makes the 2 go up. So this is 853 grams AlNO3. Remember, you must have a number, a unit, and a compound in every box. It's not optional. I'm not doing it because I like it. You must have all of those in every box. If you just write a 1 or you just write moles, I have to take points off. Okay, last example. If 36 grams of aluminum nitrate is produced, how many grams of copper 2 nitrate are needed? Okay, so we're going to start this time with 36 grams AlNO3. Remember, you don't want to write big, okay? These take up a lot of space. So just like before, let's look at our little map. We're starting with grams of aluminum nitrate, and we're trying to get to grams of copper nitrate. So grams of A to moles of A. Then we're going to use our mole ratio. Then we're going to go to grams. So the whole back side of your assignment, these 3 problems are going to be just like the examples I did with different masses and different compounds. Okay, so right now I have grams of aluminum in the top box. So that means I'm going to have grams of aluminum nitrate. It's going to match. It's got to cancel. Then I'm going to go to moles of AlNO3. Draw my line. All right, so now I'm in moles, but I'm not in the new thing yet. I got to get to copper 2 nitrate. So we're going to still cancel that out. So that's going to be moles of AlNO3 on the bottom to cancel. And this is the first time I have moles on bottom, so I'm going to circle it. That's going to be my mole ratio. Then I'm going to go to moles of the new thing on top. And the new thing is copper 2 nitrate. So let's look at our symbols. That's going to be nitrate. It's going to be the same, but it's going to be this one, CuNO3, 2. And then we're going to draw a line because we got to go all the way to grams. So one more. Right now on top, we have moles of CuNO3, 2. So on bottom, we need to cancel it. It's going to be moles of CuNO3, 2. And then we're going to go to grams of CuNO3, 2 on the top. All right, so outside of the circle, mole gets a 1. So that's a 1, and this one's a 1. Inside the circle, we're going to look at our balanced equation. In front of AlNO3 is a 2. And in front of CuNO3, 2 is a 3. So that's going to go right there. All right, grams comes from the periodic table. Well, we already found AlNO3. We just did that in the previous problem. So I'm going to go ahead and fill that in. 212.994. We found that from the periodic table. But then we have to do a mass for this one. So I'm going to grab the paper I've been using. CuNO3, 2. So we have Cu, we have N, and we have O. So 1 Cu, 2 Ns, remember it multiplies, and 6 oxygens. All right, so the mass of Cu is 63.546. The mass of nitrogen is 14.007. And the mass of oxygen is 15.999. All right, so let's get a mass there. So 1 times 63.546 plus 2 times 14.007 plus 6 times 15.999. So 187.554 grams per mole. All right, so that number is going to go in this box, 187.554 grams per mole. That's what that means. All right, so let's talk about what cancels. Grams of aluminum nitrate, grams of aluminum nitrate, moles of aluminum nitrate, moles of aluminum nitrate. They're on top and bottom and they match. Moles of copper nitrate, moles of copper nitrate. I'm left with grams of copper nitrate. All right, to solve, we're going to multiply the tops and divide the bottoms. Okay, I know this video is long, but it is what it is. All right, so 36 times 1 times 3 times 187.554 divided by 212.994, oops, divided by 2 divided by 1. So you must write things down, guys. It's too hard to remember all of that in your brain. All right, so much smaller number this time. Our first box has 2 sig figs, so the 5 makes the 7 go up, so it's going to be 48. And then grams, CuNO3, 2. So that is what I'm looking for on all of these problems, okay? You just have 6 problems. There's 3 on the front and 3 on the back, okay? And the front are not as long. They're not 4 steps. They're only 3, okay? You must have a number, a unit, and a compound in every box. If any of those are missing, I have to take points off.